Now, troubleshooting these drives can be a little bit different. Now, we can troubleshoot the mechanical aspect and the electronic aspects, but the best friend you'll ever see with your drive is the manual that came with it. Every one of the drives are going to have error codes, and every error code will be different for every make and model of drive. There is no standardizations of error codes. My point being is if this screen or this screen will light up, you can troubleshoot the drive. If there's something internally wrong, you can go through that little menu right here on here and you can find and troubleshoot internally in the drive. But it's going to come up with a set of codes. Now the problem here is without that printout or that original manual, you don't know what the codes are. Some of the drives like the AB will have a list of codes printed on the side. Others will not. So the codes themselves are going to tell you what's wrong with only the one specific type. Now, one of the points about this drive I got to make is, go ahead and let me turn this thing on, is we got different types of meters here. If I turn this drive on, hit the start button. If I turn this drive on and I bring up this frequency, let's go up to be about 10 hertz. So I got 10.3 hertz, that's fine. Now if I go ahead and take my meter and take a measurement across the output of that drive, right there, what I'm seeing on the meter is roughly about 86 volts, 86.9, 86.8. So I do get a reading on the meter. But now, not all meters are going to read that drive. If I take a standard meter you probably use right there today, and I measure the same load right there across this load, what I'm seeing on the meter is 43 volts. There's a big difference in voltage. That's because of the difference in the sine waves. The average responding meter could only read the average responding of the sine wave coming in. So if I were to measure power coming in, I'm going to get exactly what I need at 120 volts. Kind of hard to see at this angle, but I got 121 volts coming in. But now going through the drive, the sine wave changes to pulse width modulation. So now the difference here is the only type of meter that will read the output of the drive has got to be identified as true RMS. So if we troubleshoot that drive, we got to be using the right types of meters, otherwise you're shooting from your hips. Now if I go ahead and increase this, if I increase this to 60 hertz, this meter says it's exactly 240 volts. If I increase to 60 hertz, this meter tells me it's 343 volts. Which meter's right? Obviously the true RMS. So there are different meters, we have to have the different types. Now one easy method is I can take readings right here on the bottom, which I cannot get a good view with the camera. So I'm going to go ahead and take readings right here on the loads itself. If I measure right there at 15 hertz, let's go up to about 20 hertz so I don't get too bright to drown out the camera. If I measure from one phase to the next, I'm getting exactly 131.4 volts. If I measure from the other phase, I get 131.4 volts. If I measure to the next phase, again 131.3.4. So taking the readings right there across the load makes it very easy. I should have the same exact voltage across all three phases of the load. If I do not have all three phases identical in voltage, then there's a problem internally within the drive. Well, the power problems are one thing. That's easy to identify. But now the next question is, how is this drive operating? Okay, now this drive might be getting a signal from a PLC, a building automation, or another drive. Could be getting a signal to start or run from another location. If that be the case, then those signals right there that go in and out could be something completely different. There's going to be terminal strips for these types of connections. And again, it doesn't matter which drive it is, you're going to need some type of manual to identify which terminals are which. Okay, there's a lot of times these terminals have to be jumpered out, and that would complete the circuit to allow the drive to run. But then again, I can take this jumper out and replace it with a PLC input. I can replace it with building automations. There's terminals here where I can set a speed limit for the drive. There's terminals right there that tell me it has to have a voltage applied to a certain terminal to run. So there's different methods in which the drive can be troubleshot. The output is probably the first most common, to make sure you got an internal voltage that is going to be the same in all three phases. If you have differences there, then the problem is going to be internally. Something internally within that drive is failing or has failed. If the drive will not start or run correctly, it could be in the programming itself. Okay, programming itself, which again shows you error codes, but there's also programming codes throughout this drive. And these programming codes, I can go through those, and how that works is, again, I have to have the drive manual. And every one of these codes will have a different function. So that's a whole nother story based on specific types of drives. So troubleshooting doesn't have to be rocket science. We do have to know which direction to go. If there's error codes right there and there's no codes on the screen and we're not getting the proper voltages, we got a problem internally. If the drive just will not start or will not run correctly, it's going to be in a programming issue, or it's going to be in the inputs coming from another source. Very easily, you could have inputs from another source. Drives are pretty simple things, but there are all electronics. Inside of the backs of these drives, you've got some pretty large circuit boards with a lot of components on them. There's large capacitors in there. There's conversion circuits. It's also basically electronics. Now, some of the problems we have with drives is they fail. One thing that will cause failure on the drive is on the input circuit. Power coming into the drive, if this drive receives a large voltage spike or a large transient voltage, that transient voltage can kill the drive. If one drive starts the same time another one starts, or they start and stop at the same time, very easily the transient voltage from one drive can kill the next. Okay, so we might have to have some type of power filter upstream of the drive. Now, drives themselves, you look at all the vents, these two drives are exposed to the elements. If I'm in an area that's dirty, dusty, unclean, then our circuit boards here are going to gather a lot of dust and dirt and contaminants very quickly. So in other words, these drives don't require a lot of maintenance other than keeping them clean and dry. If I'm going to clean out the drive, you never use an air hose. You never use blown air of high pressure. Anything above 1.5 pounds of pressure will rip the electronics right off those circuit boards. So about the only approved method to actually clean the drive is using canned air. So in dirty locations, they need to be cleaned and maintained every so often, cleaned off on the circuit boards to keep them from overheating. You have also problems with the transient voltages coming into these drives. But another problem that happens with these drives is if you put a drive in an area that's got a large magnetic field. So if I put a large circuit breaker right next to this, a three-phase breaker, As that power from that circuit breaker flows through there, the magnetic fields will build up around the breaker and it will induce a voltage on the electronics. This is why many cabinets are going to have metal plates between the circuit breakers and the drives, the circuit breakers and the PLCs. That is an induction shield that prevents magnetic induction from creating voltages. Well, drives are most often kept inside of a cabinet, and a lot of times that cabinet is going to require airflow through the cabinet to keep the cabinet from overheating. So if that's the case, filters have got to be changed, they got to be maintained and cleaned. We have filters. Now, one other cause for drive failure is areas that are very noisy. If I have an exposed drive, not in a cabinet, and we're in an area with a lot of large noise, okay, one problem that happens is sound. Sound waves passing through the plastic of the drive onto the circuit board can induce a voltage on the electronic circuits. So these drives can fault for many reasons. Overheating, areas that are noised. There's a lot of ways these things can fault, but the fault codes will always show up right on the screens, and it'll tell you what caused the faults. So maintenance is very simple, guys. You keep them clean, you keep them dry, you blow the dust off every so often, you keep the drives in the cabinet, you keep some airflow in the cabinet, and that'll keep the drive pretty simple.